So we left off here yesterday, and we were just talking about the equation, and I want to reiterate A, this number right here is going to be the initial amount. Now, a lot of times our initial amount is just 1, and those are all the functions we've graphed so far. So y equals 2 to the x. The initial value is right here, and that means you're taking 1. So A, a lot of times, is just 1. B is a ratio. So this right here, that number, B, is going to be the ratio. So just like we found y-intercept and slope, we're going to do the same thing. We're going to find the initial amount, and we're going to find the constant ratio. So let's look at this first table right here. And I can't remember if you have this in your book or not. You do not have this one in your book, but it still will give out the information. So with these, what we need to understand is your initial amount is going to be when x is equal to 0. Okay, so when x is equal to 0, this will be your initial amount. So here, a is equal to 4. Now to find b, we have to find a ratio. Okay, now to find the ratio, it's really easy. We just go from one term to the next. So what is this going up by? What do I do to 4 to get 12? I multiply by 3. If I take 12 times 3, do I get 36? If I take 36 times 3, do I get 108? Yes, take out your calculator. Now take 108 times 3, and guess what? You get 324. So what's our ratio? 3. So b is equal to 3. So our function, f of x, is equal to our initial value, 4, times b, which is 3, to the x power. That's all you have to do. Good. Now let's look at a graph. Okay, we're still going to use that same information. Remember, f of x is equal to f of x equals a times b to the x. A is the initial amount, b is the ratio. So what's my initial amount? Where does it start? Right. A is equal to 128 because when x is 0, y value is your a. Okay, it's your y-intercept, if you think about it. Okay, but moving on, b is the ratio. What is it changing? What do I do to 128 to get 64? Looks like I divide by and multiply by 1/2. And we always have to find the multiplication because it has to be a multiplication in our form. What do I do to 64? I multiply by 1/2. What do I do to... Oh, now look right here. Now I go from 32 to 16. What did I do? I multiplied by 1/2. What do I do to 16 to get to 8? Multiply by 1/2. So what's my ratio? What is b? 1/2. So we write our equation. F of x is equal to the initial value times the ratio to the x power. Not anything too difficult. So now we have it in your book. We're going to write an exponential function, and this is on page 121. So go to page 121 if you're not already there. Okay, so what's our initial... Okay, remember our function f of x is equal to a times b to the x. So our initial value, that's right. There is my a right there. That is my a. So far I have f of x is equal to 3 times. So now what do I do to 3 to get 12? Multiply by 4. Can I take 12 times 4 and get 48? Yay! Can I take 48 times 4 and get 192? Yes. And here we go. I would have to take a calculator to find that, but I'm pretty sure it's 4. Okay, actually I know it's 4. So that's 4 to the x. So my ratio is 4. This is my initial value. Okay, now if we were in the classroom right now, I'd like you to try this next one. So I'm going to pause and let you try that. So we know that a is equal to 2,187. Yay! Now we have to find the ratio. So what I did is I took 2,187. I noticed it was going down. Notice these all get smaller. So I knew I was going to have to divide. So I took 2,187 divided by 729, and I got a 3. But I can't write it as division, so I know that dividing by 3 is the same as multiplying by its reciprocal, right? Dividing by a number is the same as multiplying it by its reciprocal. So these are going down by 1/3 every single time. So what's my ratio? What is b? Exactly, 1/3. So f of x is equal to 2,187 times 1/3 to the x power. Okay, good. So now that we know how to compare, so we know how to write an exponential equation given data, we're going to look at comparing linear equations. Okay, look at the word linear. We remember that this is a line. And we're going to look at exponential. Exponential is a curve. Now the main difference is that linear changes by adding or subtracting. Okay, let me write that differently so you can actually get all that in. So a linear equation, what you're going to do with a linear equation is that it's going to change by addition or subtraction. Okay, it's going to be a constant that you add or subtract. Whereas an exponential, it's going to change by an exponent, so it's going to change by a ratio. Okay, so here we go. Look at option A. $100 for the first week, and each week after that amount increases by $25. So if I were to make a table of this, I would say for week 0, I have $100. For week 1, I have 125 because it goes up by 25 each week. Week 2, I have 150. Week 3, 175. So what's happening here is it's going up by 25 every time. I'm adding 25. Okay? So it wants to know which one is faster. This is going to be a linear. It keeps on going up by 25. Whereas for option B, the first week, you have $1. And each week after that, it triples. So you're going to triple this. Okay? So if I triple it, I multiply by 3. So this becomes 3. That's first week is 1. $1 for the first week. And then it goes up by 3. Hold on. And the second week, now notice what you're doing here is you're multiplying by 3 every time. Multiplying by 3 every time. So you're going to get a 9. Then for the third week, you're going to multiply by 3, you get 27. See how it goes up so quickly? So right now, you're doing fine. I'm going to go to the next screen so you can see what happens. You can see at 5 weeks, it's 225. And at 5 weeks, if I'm tripling every time, is at 243. So this one is going to go up. This second one that has a constant ratio is going to go up faster because it's an exponential equation. So this one will go up faster, even though it starts off slower. Okay, it's going to go up faster because it's going to accumulate so quickly because it's multiplying by 3. So in your book on page 121, number 4, it says identify each function as linear or exponential. Remember, a linear is going to be where you add or subtract a constant. And an exponential is where you're going to multiply by a ratio. Okay, you're going to multiply by a ratio. So f equals the number of branches at level x in a tree diagram. So here's level x, and it says where each branch extends is 4 places. And then that one, so if I have these branches here, it's going to extend 4 places. They're each going to go 4 places. So what kind is this going to be? It's going to go up by a ratio of 4, so this one is going to be an exponential. Because my ratio is 4. That's my ratio. Okay. B, f of x equals the number of boxes in row x of a stack in which each row increases by 2 boxes. There's our big hint. Each increases only by 2 boxes. So this is going to be a linear. Now, one of the things that we're going to do when we get ready for the EOC test, and it's consistently on there, is you have to identify if something is linear, exponential, or what we'll call quadratic, which we have not learned yet. So we'll learn that too, and that's something that will show up. And it will be from a table. It will be from a table that we'll see if it's a linear exponential like an earlier problem. Okay, moving on. This habits of mind is a really good one. It says in an exponential function, y is a non-zero constant and b cannot be equal to 1. Well, let's look at the function. F of x is equal to a times b to the x. Well, if y is a non-zero? Well, look, if I put a 0 in there, what if I take 0 times anything? that's going to give me 0. So my function would just be 0. So that's the reason we have to specify a is non-zero. Now let's look at b. What if b were equal to 1? Well, if b were equal to 1, no matter what my exponent is, it's always just going to be 1 times it. So that's the reason b cannot equal 1. Okay? Good. So this page gives a really good summary. And again, all its information, I'm taking all of these slides from your interactive book. So you can always use that interactive book. But it just points out that if b is greater than 1, and we've written this down someplace already, if b is greater than 1, so if b is greater than 1, okay, like when we had y is equal to 2 to the x, b is greater than 1. We have a function that continues to go up by that same ratio, so this is what our table looks like, and then our graph is going to start and it's going to increase. So when b is greater than 1, it's going to be an increasing function. Now when b is between 0 and 1, it's not less than 1, it has to be between 0 and 1. In other words, this is a fraction. If it is a fraction, notice that my function is going to decrease. It's going to come down. So this is a decreasing function. Okay? So just keep that in mind when you're looking at these. I don't know what that is. Okay? So decreasing. But this just kind of summarizes what we've been talking about too. You can always pause and write this down in your notes if you'd like. Okay, so now let's go to the essential questions. What are the characteristics of an exponential function? Well, if b is less than 1, we have that, and then if b is between 0 and 1. So let's talk domain. Domain for all of these is going to be all real numbers. All real numbers. Okay, that's our domain. Our domain for this one is all real numbers. And this is where using that double back R might be easier. Remember, you make 2 lines, stop at the top of this one, come to the middle of that line. That stands for all real numbers. Might be a little faster. Okay, so for both, it doesn't matter which function. If b is less than 1 or b is between 0 and 1, we can plug in anything for x. Now the asymptotes that we have had so far, this will change, but for our function, f of x is equal to a times b to the x. Our asymptotes are going to be, for now, y is greater than 0. And because of that, it affects the range. So the range, I misspoke. That should be equal to. Thank you for catching that. Equal to, because your asymptote is a line. Your range is the set of numbers that make it true. So y is greater than 0. Never is it equal to, because it's an asymptote. Doesn't go any further. Look for relationships in number 2. How can you tell whether the graph of a function of the form f of x equals a b to the x if a is greater than 0, will increase or decrease from left to right? Well, a is greater than 0. Okay? It doesn't matter what a is. It matters what b is. Okay? And that's what we were just talking about right up here. If b is less... Okay, I wrote that wrong. This is supposed to be that b is greater. Whoops. B is greater than 1. I just realized that. If b is greater than 1, okay, if b is greater than 1, then it's increasing. If b is between 0 and 1, meaning it's a fraction, less than 1, then it's going to be decreasing. Okay? Good. Okay, number 3, why is b not equal to 1? And we just talked about this in our habits of mind. Because if I have b being equal to 1, well, 1 to any power is still going to give me 1. Then I'm going to take 1 times a. That's just going to give me a number. So it's going to be kind of like ridiculous. So no. Okay, error analysis. Martin says that f of x is equal to 2 times 4 to the x. Starts at 4 and has a constant ratio of 2. So let's remember our function f of x is equal to a times b to the x. Okay, a is always your initial value. B is your common ratio. Okay, is that what he did? Starts at 4. Nope, it has to start at 2. Starts at 2. And it has a ratio of 4. So he just switched them. Okay? So now we're going to write the exponential function. Again, let's write out the general form. F of x is equal to a times b to the x. A is your starting value, your initial value, and b is your common ratio. And so this is what you would have, like on the EOC, we would look at tables and we would decide if they're an exponential, a linear, or a quadratic. And we'll do that more after we learn quadratics. So our initial value on this one right here. So a is equal to 4. Now we have to find b. To find b, we have to find out what's happening every time. So what happens to 4 to get 2? You're dividing by 2, right? We can't write divide by 2. We have to write it as a multiplication because this is a multiplication problem. So it has to be multiplication. Okay? So multiplying by 2, dividing by 2 is the same as, okay, so think of fractions. Change, flip. Keep, change, flip. So division goes to multiplication, a whole number goes to its. So if I multiply by 1/2, 4 times 1/2, does that give me 2? If I take 2 times 1/2, 2 times 1/2, does that give me 1? If I take 1 times 1/2, well, that's an obvious. So your ratio is 1/2. So I have f of x is equal to 4 times 1/2 to the x. Okay, try this next one on your own. Pause your video and write the equation, the exponential equation for this table. Go. So again, we know our initial value right here, but we have to have x has to be equal to 0. So a is equal to 3. Now we have to see what happens every time. What do I do to 3 to get 6? Multiply by 2. Do I multiply by 2? Do I multiply by 2? Do I multiply by 2? So my ratio, b, is equal to 2. So f of x is equal to 3 times 2 to the x. Okay, good. And that's it. That's all there is to this lesson. So not so bad. We're now done. So now you can finish up the assignment for 6.2. And remember that once the teacher, the first day after when it's assigned, then you have 2 days in order to do that assignment. But check with your teacher as far as when that is due. Thank you so much. If you have any questions, you know where to find us.